Hello Pre-Calc BC. Today we are moving on to graphs of functions. This is section 2.2. So go ahead and find your notes and we will get started. All right, so here we go. The focus of today's lesson is basically looking at graphs and identifying information about them, and also looking at different equations and identifying certain aspects about their graphs. So if we take a look at a bunch of these problems, this is something you may want to just pause and try to run through this whole first side yourself. If you want to do that, that's fine. But then make sure you come back and you actually watch and see what the answers are to the videos. I'm just going to go through and teach it, so you're welcome to watch it with me, or again, feel free to pause and try to fill these in yourself. So f of 0, this is just saying, hey, what's the y coordinate when x is 0? And that would be at this point right here, and that's the origin, so the y coordinate is also just 0. Okay, f of 6, well, that's also an x-intercept or a 0, so our y coordinate is again just a 0. F of 2, that would be down here, our y coordinate is -2. And f of -2, that's over here, our y coordinate is a 1. Okay. Is f of 3 positive or negative? So again, it's for f of 3 is referring to the y coordinate when x is 3. 3 doesn't appear on our graph, but we can certainly find where it should be and come down here, and f of 3 would be a negative because our y coordinate is a negative. For what number is x? Is f of x equal to 0? So again, f of x is referring to our y coordinate. So they're basically asking for your x-intercepts here, or your zeros. And your x values would be at 0, at 4, and at 6. Okay. For what numbers x is f of x less than 0? So if f of x is less than 0, your y coordinate is less than 0, which occurs over this interval right here. So you have two options. You could write this as an inequality. You could say 0 less than, or what you're going to see a lot of is interval notation for this situation, and it would just be written like this. This can get a little confusing for people because you think of it as an ordered pair of 0, 4. So be aware that now when you see parentheses with two numbers, that's sometimes referring to an interval. This is saying between 0 and 4, just like we did interval notation for your domain. We are putting parentheses and less thans here because 0 is kind of, right, it's 0 and 4 are both where your x-intercepts are, so it's kind of it's the location right where we go from positive to negative. So we're not including those values because those aren't actually less than 0, if that makes sense. Domain of f. So domain are our x values. Our lowest x value is -4 and our highest x value is 6. And those are both closed dots. So I'm going to go ahead and use interval notation with some brackets. Okay, because we are including those values. Range, we're going to do the same thing, but you're looking at your y's. Lowest y value is a -2. Highest y value is a 3, and again, those are actually closed dots, and so I'm going to go ahead and use interval notation with brackets. All right, jump on the interval notation train, guys. It's really good. We got some people who are usually like, no, set notation for life. You'll change your mind, trust me. X-intercepts, all right, well, those we can just list. 0, 0, 4, 0, 6, 0. Y-intercept, just 0, 0, right? Find x when f of x is 3. All right, so f of x is 3. They're saying your y coordinate is 3, which is happening right here. So our x value is 5. Find x when f of x is -2. So again, they're saying your y value is -2. That's happening right here. So our x value is 2. Okay, there you go. moving on, we have these two graphs, and we want to use the vertical line test to determine if the graph is or is not a function. If it is a function, we're going to find the domain and range, we're going to find any intercepts, and we're also going to talk about some symmetry, whether the graph is symmetrical, words are hard, over the x-axis, y-axis, origin, or none of these. And symmetry is something we're going to talk about a lot in our next lesson, 2.3. Okay, so first things first, vertical line test. We should be able to say, yes, this is a function. Okay, so I'm going to write that down, function. So since it's a function, we get to do all of these other parts. Hooray! All right, domain. Well, it's a parabola, right? And parabolas have a domain of all real numbers. Okay. And for my range, I can see that the lowest y coordinate is, or lowest y value is a -1, and then it goes to infinity. So this is really great to use interval notation for. I'm just going to say -1 to infinity. Or you could say y such that y is greater than or equal to -1. But look how much faster this is. Okay. B, intercepts. We have two x-intercepts, which are at -1, 0 and 1, 0. And we also have a y-intercept at 0, -1. And then in terms of symmetry, this would be symmetrical over the y-axis, right? Because it's a mirror image on either side of the y-axis. And we actually have a name for this, which we will talk about in your next lesson. Okay. All right, so let's do the same thing for this one. Again, feel free to pause this and try it yourself. Just make sure that you actually come back and check your answers. And that's something that you can always do for all of these videos. I want to make sure I teach every single problem, okay, because that's like my job. But you are always encouraged, once you see what we're doing, to pause, to try it yourself. Just make sure you actually come back and watch the part of the video you need to check your answers. Okay. So again, this is also a function. It will pass our vertical line test. I'm abbreviating this time. My domain. So my x's, I'm going from -pi as my lowest x to +pi. Okay, and I am using brackets because it does specifically include -pi and end at pi. And then my range, I'm going from -1 up to +1. Okay, intercepts. I've got some x-intercepts at -pi 0 and pi 0. And I've got a y-intercept at the origin. And then symmetry. This is actually going to be called symmetry over the origin. And we're going to get into that a lot more in our next lesson, but you can kind of almost think of it as a rotation if you'd like. Basically, like, think about taking that part right there and it's being rotated to become this other part. You can also think of it as two separate reflections. It's being reflected over the y-axis, so it'd be like this, and then it's being reflected over the x-axis again. Okay, and there are some characteristics, another challenging word, that we'll talk about in our next lesson. Okay, all right, so that was examining graphs. Now we're going to go ahead, we're going to examine some functions, some actual equations, and determine some information about their graphs. So for A, we have this guy right here, and we want to know, is that point -1, 2, is that on the graph of f? Well, really all we have to do here is find f of -1, right? We're just going to plug our -1 in for x, and we're going to see what we get. Okay, so I'm just plugging -1 into the function there, and then let's evaluate it. 1 times 2 is 2, 2 plus 1 is 3, 3 minus 1 is 2. And 2 is what we were supposed to get. So I'm going to say f of -1 is equal to 2, so this is a yes. So that point is on our curve. If x is -2, what is f of x? What point is this on the graph? Well, this is just a fancy way of asking what is f of -2. So again, we're just going to plug -2 in for x. And just please be careful with your signs as I mess up my sign. All right, so mental math again. 4 times 2 is 8, plus 2 is 10, minus 1 is 9. So what that would tell you is that you are dealing with the point -2, 9 on the graph. Okay, is f of x equal to -1? What is x? What points are these on the graph? And just a comment here, you could certainly do all of this on your calculator. You could just plug these numbers in. However, this would be a question I would expect you to do without a calculator. You should be able to do it without graphing. Okay, you should be able to do it strictly algebraically. So that's why we're doing it this way instead of typing it into our calculator. If f of x is equal to -1, what is x? What points are these? Or what points are on the graph. So now this is my y coordinate, right? So I'm going to plug -1 in for y. This would be a really great one to graph and just find your intersection points, but I don't want you to graph it. So we're going to solve it algebraically. So to do that, I am going to factor. So I'm going to add my -1 over, and it actually is going to cancel with my other -1. And then I should be able to factor out an x. Okay, and then I'll just do some zero product property and set each of these guys equal to 0. So that'll be an x equals 1/2. Okay, so those are the two x's when the y is -1. So the points on the graph would be 0, -1, because my x was 0, and 1/2 -1. And if you were to type this into your calculator and do your second trace 5, enter, 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 those would be the two intersection points you would get. Okay. What is the domain of f? Use both set and interval notation. Well, f is a parabola, right? It's a quadratic, 2x squared. So we should know that our domain is just all real numbers. So we can say x such that x is an element of all real numbers. Or for interval notation, -∞ to infinity. Okay. And last one for this part, we're going to list our intercepts. So the important thing in finding your intercepts when you are not using your graph, okay, because we want to do this without our graphing calculator, is you need to remember what our x and y intercepts actually mean. So when you have an x-intercept, right, that's just when y is 0. And likewise, when you have a y-intercept, x is 0. So really, you're just plugging 0 into these different variables to help you find the intercept you need. Okay, y-intercept is usually easier because you can just kind of look at it, right? If I plug a 0 in for x, boom, boom, that cancels, we get -1. All right, that's it. So f of 0 equals -1, so your y-intercept is 0, -1. You also may have already known that because of that point right there. Okay, x-intercept is a little more work. So we have to plug a 0 in for y. So let me do that. 2x squared, what is it, minus x? Minus 1. And then this is something that you'd either have to factor or quad formula, but we can factor it, so let's do that. Okay, 2x times x is 2x squared. 1 times 1 is 1, and I need a positive and a negative here. So I think it should be this. Let's see here. Negative 2x plus 1x is negative 1x. Yeah, so there you go. And then you're just going to go ahead and we're going to do zero product property. And you should get a negative 1/2 and a positive 1. And so that tells you that your x-intercepts are at negative 1/2, 0, and 1, 0. And again, you can verify that if you graph it and do your second trace 5, enter, 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 if you'd like. Okay. All right, so we're just going to do one more, and it's the same type of problem. The function is just a little different. So again, if you feel like pausing it and doing as much of this as you can yourself, feel free. I'm just going to go ahead and keep on teaching. Okay, rational function this time. We have that x plus 1 in the denominator. Is the point 1, 2 on the graph of f? All right, well, let's find out. I'm going to find f of 1, and I'm just plugging a 1 in for x, and I get a 1/2, and it's supposed to be a 2. This is very sad, so this is a no. Okay, didn't work. If x is negative 2, what is f of x? Okay, well, this is just asking for f of negative 2. So I'm going to just plug a negative 2 in place of x. And that should give me a negative 1. So my point would be negative 2, negative 1, because my x was negative 2 and my y coordinate I got was a negative 1. If f of x equals 1/2, what is x? What points are on the graph? All right, again, f of x is your y, so I'm just going to plug my 1/2 in up here. And now this is like one of my most favorite things, not really, but I have the saying, when in doubt, cross multiply. So that's what we're going to do. We're going to cross multiply, and we'll get x plus 1 equals 2, and we'll just get x equals 1. So the point on our graph would be our x is 1 and our y coordinate is 1/2. Okay. Domain of f. Well, this problem is different from the one before. We do have a denominator, so we should be able to see pretty easily that x cannot be equal to negative 1. Otherwise, we do get a 0 in our denominator. So for our domain, we can say x such that x is not negative 1, or interval notation. I wouldn't recommend it for this problem, but we could say x can be anything between negative infinity and negative 1, but it can't be negative 1, and then it can be anything between negative 1 and infinity. Okay, so any value except negative 1. Okay, and finally, intercepts. So same rule as before, right? When you want to find an x-intercept, that's where y is equal to 0. And when you want to find a y-intercept, that's when x equals 0. So y-intercept is always going to be easier. We're just plugging a 0 in for x. And you're going to get 1 divided by 1, which is 1. So 0, 1. X-intercept, we plug a 0 in for y. And again, when in doubt, cross multiply. And it actually, look what happens. You just get a 0 equal to, even, I mean, like it wouldn't matter what was down here. It's 0 equals some number, right? I'll just say 0 equals 1, which can't happen. So what this means is there is no x-intercept. Now, if you graph this, just to give you an idea, this is a rational function, which is something we're going to talk about a lot in our next chapter. It's like what our whole next chapter is on. But what you may recall is because there is an x plus 1 in your denominator, we have a vertical asymptote at x equals negative 1. We also have a horizontal asymptote, which we'll get into later, at y equals 0. So your graph would look something, whoop, that went a little too low, something like this. It's not crossing that horizontal asymptote, which is why we don't have an x-intercept. All right, so there you go. There is your 2.2 notes. And let me know if you have any questions. I hope you have a great day. See ya.